Alright, good morning. We're starting a new chapter today. Factorizations over. That doesn't mean we won't be using again. We will of course use it, right? Even in this section we will use factoring skills. And I've seen you guys, some of you guys are getting too comfortable with this class and lacking doing homework, okay? So you're kind of falling behind. Even though you got a great score in exam 1, that doesn't mean it's sustainable unless you keep working at the same discipline. You need to work, practice. Math is learned best by practice. It may sound okay when you come here and understand stuff, but unless you sweat on your own, you will struggle, okay? And material will keep piling up, like one section every day. So please keep up with the fast pace. I'm sorry, but we need to cover all these. I wish we could have more time and go slower, but so keep up practicing. And let me know if you are struggling with homework. Come to my office. This question I can't figure out, we can go over again and submit your solution, see what you're doing wrong, okay? But there is always a mistake on paper solutions. Don't blame the system. Computer is smart, is taking the right answer. It's just there is a mistake on paper. I can find it quickly for you. Alright, anyhow, we are starting rational expressions. We're gonna deal them for a while. There are 7 or 8 sections here we need to cover. So it's a lot, and maybe this is one of the most challenging chapters in this course. So take this serious. Try to make most out of the class. Ask here and practice. Don't give up, because this stuff can be a little hard to grasp at first, but we'll hopefully pass this issues quickly, okay? Now, ratio is the key word here. Rational. You see the word rational has first 5 letters as ratio. So you expect to see a ratio a lot in this section. And ratio basically means something with a numerator and denominator. I call it top and bottom. You see 2 sides, top and bottom, separated with a fraction bar. That is called a ratio. And if top and bottom are both numbers, we call it rational number. It's a rational number if both sides are number. However, if either side, top or bottom, may involve letters like X, Q, R, S, sometimes all together, all 4 letters, 5 letters together, with several powers, exponents around each letter, then we call these rational expression. The word expression shows up if you have letters and numbers together. It can be purely numbers, still a rational number, you can call it expression as well. Still a rational number called a rational expression, but more specifically we get to see some x's, y, z's with powers. And we're gonna learn how to treat them, how to simplify them, and what values to avoid in those variables, etc. Our first task with those expressions is very simple. I'm going to check your skills of substituting a number into variable and simplifying it. So basically in question number 1 and 2, you will simply evaluate. This is called evaluation. Evaluate the expression in the specified amount. So they told us W is becoming 0. So you need to make all W's 0 in this expression and simplify the result. So we have 0 plus 9, 9 times 0 minus 6, and you need to simplify, don't leave it like this. And I know at this stage some of you guys will have troubles, trust me. Okay, what is 0 plus 9 on the top? 9. What is 9 times 0 minus 6? Because 9 times 0 is 0, and then we take away 6, it's minus 6. Again, order of operations important. You need to perform multiplication first. Some people do 0 minus 6 and multiply by 9. So they multiply 9 and minus 6. No, you need to perform this first, then subtract. So are we done? 9 over 6 is what we are going to enter? No, we always, once you get to the final result, look for a final shot, which is reduction. How do we reduce fractions? You need to break top and bottom. If they are only numbers, try to factor top and bottom into simplest factors, divisors. So what divide number? What factor? What 9 splits into? 3 and 3. How about 6? 2 and 3. And if you use something common on top and bottom, you can deduct, you can remove those common items by crossing out like this. In other words, you're kind of taking this ratio. 3 over 3 is 1. And 1 doesn't change anything, so you can wipe it off. And the result is 3 over minus 2. Now, there are several ways you can treat this minus. Some people keep it in the denominator. Some people can move it to the top. But usually we prefer to bring it outside. So there are 3 spots you can use the minus. Bottom, top, or in front. I like the in front option. We like in front option. Bring this minus all the way to the front. Like plus and minus divide each other to minus. And you have minus of 3 halves. You do not have to change this into decimals. 3 over 2, everybody can compute this by their calculator as 1 over 1.5. But if you do that, it may say incorrect in Connect Math. We like just the rational values as it is. Okay, so that's it. The first question is, I want to test it. 1.5, do you like decimals, the system? No, I don't like it. Okay, then I'll give you minus 3 over 2. And you will use ratios here a lot, so you will be using this button all the time. But I use slash from the keyboard, and it goes immediately denominator, and it likes this way. Okay. I want you to try number 2 on your own. Wow, what a mess! But the idea is the same. You are gonna make each and every A 9. And tell me your result, please. Anyone? Come on, you should have been done. Where's the mouse? Yeah, anyone? Something weird going on here, right? Or not, I don't know. Tell me, if you have an answer, tell me. Speak up. Alright, I hear somebody said undefined. I don't know what that means. I was expecting a number. Anyone has a number answer? 8.75. More? 1 over what? 1 over 5 over 0?
No, 105.
105, okay. 105 over 0. More answers? Okay, let's do this together. I put 9 everywhere, right? 9 plus 6 in this parentheses. 9 minus 2 in that one. 9 minus 9. 9 plus 3. Well, we need to do parentheses first. This is 15, this is 7. So it's 15 times 7 on the top. And this is 0, and that's 12. 0 times 12 on the bottom. Oh, you meant 105. Okay. And you got on the top 105. And on the bottom, 0 times anything? Okay. This answer seems correct, but technically you can say more about a number divided by 0, which is this word, undefined. Okay, here is the situation happening. If you have 105 on the top and 0 on the bottom, and 0 on the top and 105 bottom, one of them in real life makes sense, the other one is impossible to happen. Like, this means you have no money, you're broke, you have no money at all, but there are 105 people you owe to. How much money does each person get? Nothing. Alright, they come after you, okay? But you give them nothing. Sorry, man, I don't have money. Alright? But here is the situation with this one. You have $105, okay? And you need to spend it, but you can't give it to nobody. You're not allowed to, okay? And can this happen? No, everybody can spend $105, right? But they say you'll be dead if you don't spend it, okay? I mean, and you can't spend it. There is nobody on earth you can, on your own. There is nothing. Okay, so this is not meaningful. Everybody can spend it somewhere. This is undefined, but this is 0. Okay, so when you hesitate, just make sure you have your own story to remember which case was what. This is undefined. 0 on the top, number on the bottom is defined. This is fine, this is 0. So here the answer is undefined because it really doesn't make sense. Or some people explain the situation as breaking a stick. You have 105 foot long stick. You want to break it into 0 sizes. How many pieces do you get? Right? But 0 size is dust size. You need to make it a dust. And so that's impossible. Alright. So we just learned a fact that this is great. Because I had a feeling that I can choose any number I wish for and compute it. And I hit the wall here that some values makes the expression invalid. This is an invalid case, or undefined is much more proper way, or breaks down. I mean, your function is not operating. Your machine is completely failed. So some values are not allowed to go into the variable. Did you get this lesson? Important, because we're going to see next that some values are bad for you. It makes you sick. It makes the function sick or expression sick. Those values are called restricted values. In the next 2 questions, we are going to spot those values and get it out of our way. Okay, we shouldn't be picking them. Alright? So, how do we go find them? They are the values that makes the denominator 0. right? Wasn't it that value? It made my denominator 0. So you need to go find the numbers that makes your denominator 0. Set the denominator equal to solve and see what values make it 0. Okay? Those values are the ones we call restricted. Alright, so let's do this in question number 3. Now, forget the top. I don't care about the top. I don't even know why they're giving us. I don't need it. They want the restricted values. You must focus on this part, guys. Okay? And what do? Recipe says find out what number or numbers make this 0. So I will literally check out the worst case scenario and set it into 0. Now you found the luggage on the road, right? There are two options can happen. The luggage may have a bomb in it, or it can be money in it, right? What would you do? But you're curious, dead curious. What would you do? You open it, right? Right? And see, you either die or you get rich. Now you turn the money into the police, of course, right? You good guys, okay. So this is what I'm doing. So they are saying that there is a hiding bad guy in these numbers that can make this undefined. So I'm just really opening the luggage and seeing the bad guys. I'm setting it into 0 and see what really makes this function blow up. Set it into 0 and see if it's gonna, the luggage is gonna blow or not, okay? So I need to figure it out. How? Alright, this is section chapter, the last chapter we did. This is section 6.7. We just finished right before this. And some of you guys were in farm science thing, right? You missed it. I'm sorry, but I hope you watched the class video. How did we do this last time? You have two parentheses, set it into 0. We called it 0 product property. If there are two numbers, set it into 0. You know two numbers multiply each other and make it 0. We know either one of them can be 0. So we used this fact and said, what did we do? Wednesday? We literally split this into two pieces. There are two pieces here, but glued together with a multiplication. We separate it and do what? Just separate and leave alone? Set it into 0, yes. We set each piece into 0. Again, if the two numbers multiply into 0, either A is 0 or B is 0. I'm doing that. Either the left side is 0 or the right side 0. And we need to just solve this. Subtract 7 from this and add 3 to that, so we can get W and 2W alone. This is 2W equals minus 7. This is W equals 3. This is already a solution. Once W is completely isolated, you stop there. We don't stop on the left because it's not been isolated yet. And we're done. These are bad numbers. What do I mean? Bad means restricted numbers. You should avoid inserting them into function, restricted values. Okay? Any questions? Alright, how do we enter these? Number 3. Alright, expression has 2 of them. By the way, you usually have as many as the pieces. I see 2 pieces here. I expect to get 2. So you can get the first one done quickly by just looking at the denominator by the looks. The second one is you need to compute them, and we got 7 over 2. Negative 7 over 2, right? And 3. Did I get negative here? Yeah. Okay. Alright. The next one, number 4, is uglier. Why? Why number 3 it was easy, kinda easy. Number 4 is more challenging. Same thing. Same statement, restricted values. Why do you think number 4 looks worse? We don't have any parentheses, right? Why? What's the meaning of having parentheses? This means factored. Somebody already factored for us. Thank you, thank you, thank you, whoever did this, right? Because factoring is a challenge for us. Then somebody factored this. Unfortunately, they forgot, they got lazy and didn't factor this. Why do I need to factor things? Why do I need to things factor? So that I can set each individual P0. You cannot set each individual P0 here. This is absolutely ridiculous. Don't try to set these into 0. I see somebody tries to do this. No, you can't set each piece into 0 unless they are in parentheses factored. You need to factor this, guys. But I bet this is something you have done before. Look at this. T squared 4t minus 12. What is it?
AC method?
You can do AC method here, but AC method is a shotgun, powerful method, and this is just a fly. You don't want to kill a fly with a shotgun, right? There is an easier way for this problem. Again, AC method works. I like it. Okay, it works, but it's just too much power. What is this number? If it's 1, we do trial error method with sum and difference, and sum and product. This is the product you need to meet. This is the sum you need to make. You just guess 2 numbers. Their product is minus 12 and sum is 40. Some day earlier I did it this way. So the product you're trying to meet is 12 and the sum you're trying to make 4. What 2 numbers achieve that? 6 and negative 2. Let's try 6, negative 2 here. When I multiply 6 and negative 2, do I get negative 12? Yes, I do. When I add them, do I get positive 4? Yes, we do. Perfect. So I can go ahead and say that t squared plus 4t minus 12 breaks into 2 pieces. I need to set this into 0, right? Eventually, I'm setting it into 0. And breaks into 2 pieces. tt first. T squared is always tt. And the left number goes to anywhere you wish. The right number fills up the remaining space. So you have brought this question into this format. Somebody already did it for us in number 3. Here you did it on your own with this work from section 6.2. This was in 6.2 or maybe 3. I'm not good with titles, but either 2 or 3. Check out. We did many questions like this. This is a leading term 1 trinomial factorization, and you did plenty in the exam and homework as well. Alright, we're not done yet. What is the next stage? Yeah, set each one into 0. T plus 6, 0. T minus 6, 2 is 0. T is negative 6. T is 2. You just take the opposite of these numbers at this stage. Put it to the other side by subtracting 6 from both sides and adding 2 to either side here. Get minus 2 and 2. Are we good? So the story we got here is sometimes the denominator needs to be factored by yourself. You need to do that unless it's given in parentheses. Perfect. Alright, we are starting simplifying rational expressions next. Any questions up to this moment? Alright, you have already done this. in number 1. Here we are already seeing how to do that. Once you're giving two numbers, one on the top and one on the bottom, you break it apart to simpler numbers, cross off the matching ones. That's how you simplify rational numbers from 1050 before this class or in high school. You just need to break numbers, cross them off, and the result is remaining numbers. This is all knowledge. What is new today? How do we do this if you don't have just numbers but variables? It's the same idea. Just like you factor 21, you need to factor top and bottom if possible. Sometimes impossible, so you can't. But if possible, you do it. By doing what? By running all those past sections, 6.1, 2, 3, etc. What is in 6.1? Greatest common factor. Is there anything common between 2 and 6? Yes, there is. 2. This is 6.1. Section 6.1, finding greatest common factor and pulling it out. You have factored the top. What section is this from? What fact have they used here? Do you guys remember this? It's square difference. 6.5 or 6. 6.5 or 6. Square difference means if you have, these are squares, two squares and a minus in between, you can separate this way. And you may say, oh, wait a minute, this is a square, but this is not. No, the second one is a square as well. 9 is 3 squared. So it's x squared minus 3 squared. You first put plus between them, x and 3, and then a minus between them, and then there you go, you're factored. Once you see the factors matching on the top and bottom, you can cross them out, and this is the result. Okay? Factor, using all chapter 6 ideas, cross off. This is it. That factoring can be a challenge, let me not tell you, unless you study chapter 6 well. So if you are having issues still with chapter 6, this is the moment, this is the week before Monday. You need to clear that. You need to finish all your homework on chapter 6. Not just finish. If it's taking too long time, go hit practice more and get random questions and practice them in Connect Math until you can factor any question quite fast, efficient. Okay? So we are going to do this on the following questions. Easy, moderate, easy. I will say easy, this one, and then moderate, hard. Okay? I mean, the rest is simplifying. Yeah, we will simplify. This is harder. And going back to some trick, that's it. Okay? So the rest is, you see, we will keep factoring things, canceling things. That's it. Alright, let's do number 5 first. Why don't you try this on your own? Number 5, 30 seconds. Okay, first right answer will get a reward. So even you're wrong, speak it out. Maybe you're right. You never know. Say it again. N to the 5th divided by 2. Any different answer? Maybe she's wrong. You can steal the point or steal the reward.
3 halves n to the 5th.
3 halves n to the 5th. Okay. this, n to the fifth is matching, but different numbers. Anything else? Any number else? If it's different, say, because you're missing a chance to get a reward. I don't say what the reward is. I'll give you a star on your notebook.
1/2 n to the fifth.
1/2 n to the fifth. Alright, these two are the same. Okay? I mean, this has also 1/2 invisible. So, it's not different, but I appreciate your response. And any different answers? No? Okay. Alright, let's see. Oh, here is the reward. Every time you hit the right answer, you get half attendance credit. Like if you get 2 right answers, first time responder 2 right answers, you get 1 attendance credit. That means you can skip a day and still get attendance credit. It's not a reward for those who like this class, right? Why would you want to miss this class? Come on, right? I don't know. I mean, of course you get also. I mean, I will know who's talking, who won't, so it will count somewhere, even if you don't want to use it for attendance. Anyways, so how do we do this? We need to just break up all numbers, big fat numbers, and expressions possible. So 3, can you break 3? No, I don't think so. How about 6? Can you break 6 on the bottom? Yes, I think so. 2 times 3. Okay, next. Some people want to break powers like this. N to the 6th means n how many times? 6 times n multiplying itself, and there is a single n, you can't break it. And what happens when you see matching factors on top and bottom? You take a color pen like this and start crossing off. And recombine leftover items. You need to combine them. Don't leave n's like this. How many n's do you have now? 5. And what is left on the bottom? Only 2. Nothing else. So n to the 5th over 2 is the final answer. Okay? Alright, next. It's pretty much the same idea. Any answers for the second one? Yes?
3s squared over r cubed.
3s squared over r cubed t. That's it? Okay. Here's one candidate for a reward. Anyone else?
3s squared over negative r cubed t.
Okay. Any different answers? Come on. Going once, twice. Any final answers other than these two? Alright, let's do this. First, break 81 as much as you can. 81 is, just pick 2 numbers to break it. Any 2. What 2 numbers multiply to 81? 27 and 3. I would come up with 9 and 9, right? But you guys are smart. Alright. Alright. Sometimes you don't have to break all the way down to the simplest cases. Like this is breakable and this is locked. But you can stop breaking if you can foresee something happening. Like I see 27, 81 breaks into and 3. I want to stop here. Why? Because you see the same 27 down there with a minus. But is it wrong if you keep breaking this up? 9 and 3 and 3 and 3? No, it's still correct. You get 1, 2, 3, 4 threes here. This is 1, 2, 3, 4 more threes from 27. But if you break 27, you need to break this one as well. And they will cancel anyways. If you see already in the mid step something matching, you don't have to break to the simplest numbers. You can stop breaking. But if you are completely clueless seeing that, yeah, break 27 all the way. This is gonna make 327 is triple 3. I have one extra 3 which is not needed. 27 is triple 3, so they cancel if you go all the way and break things. But it's not necessary. They cancel anyways right here. Okay, let's break R. I don't have to, it's already single. S to the fourth is how many? 4. And T squared is double. R to the fourth is 4 of them. And some people don't even need to split this. I mean, I'm doing it for the first time, but you have 4 R's here. One of them is dying with this. How many left survivors? 1, 2, 3. So some people can immediately do this on top of their head and say, oh, this is already cancelled and it's R. They say they do this. R to the fourth cancels with this and it's R cubed left. You have 1 died, 3 left. And same way, S to the fourth. They don't separate S's like that. They do S to the fourth and they compare S squares. Oh, 2 of them are dying. So there is 2 left and there is nothing left here. 2 left on the top. T squared and T cubed. 2 of these gone with this and there is only 1 T left. T cubed becomes T to the first. Okay? 3, 2, 1. You count back. 2, 1 is just 1. So we have, what is left? 3. Survivor 3. What else? S squared. Nothing survived here. A minus sign survived. Okay? And a cube of R and a T. Alright, we have a winner here. Okay? Can I pull this minus in front here and say minus 3s squared over r cubed? Yeah, that's perfectly fine as well. You can even put it next to 3 if you wish. It's up to you. Okay, number 7, I said easy. Why? Because here at least you broke some stuff. Factors, right? You split things apart. This one, it's already been done for you. They already factored, although you have variables still there, but it's already been factored into 2 groups. And can you break this more? Can you break these guys more? No. T and 9 is already simple enough. They are not square difference or they are not quadratic. They are already linear, single powered, so we can't break them. So all you need to do is search what's common on top and bottom. These 2 as a block, cancel. And T minus 3 and T plus 8 is the answer. Now I'm going to mention some misconceptions. I believe some of you guys, at least half of class, has this misconception. So I want to clear that. So is this final answer first clear? Clear to you? Let me type it in so you know how to type complicated things. So if you see a fraction as a whole fraction in your answer, start with a fraction symbol, please. This one. Then fill up the top, which was T minus 3, right? And go down with the arrow key or click with mouse. Clicking with mouse can be sometimes challenging, but if you hit the lower arrow key in your keyboard, it goes down and says T plus 8, was it? So this is how you check your answer. I want to talk about some misconceptions, mistakes possible. Such as this one. T plus 9. It's a new question. Consider it T new question. And I'm making this T minus 9 and let's say T something else. What is matching on the top and bottom we can cancel out? Nothing? Are you sure?
All the T's.
All the T's, right? Who said that? Great. So, like, not only T's, I mean, we feel like these T's, and also 9 is matching. It's just plus and minus left. Plus and minus makes minus. And I can cancel this T. And let me make this 9. Oh, I can also cancel 3 and 9. This makes 3. This is completely ridiculous. Don't do this. Okay? We cannot cancel that way. It's absolutely wrong. Why? Alright. What you were doing was right. If these were products, yes, you could do all this. What I did was completely correct. You could have canceled these, that, if everything was a product. That's the power of product. So they are all glued together with multiplication. Yeah, you can individually cancel them. Individual cancellation happens if the operation among terms is product. But if it is plus or minus, addition or subtraction, this is a block. Block means they are bonded together. They are not separable. They are like twin brothers. You need some surgery to separate them, and you can't do it. Okay? It's impossible. This is a block, and this is a separate block. They only cancel each other if entire 3 items are the same. T must be same. 9 must be same. Yeah, they are the same. And more importantly, these signs must be same, so I can cancel it. If this is plus, this is minus, they are separate things. This is block 1, this is block 2. Not the same. We cannot cancel them. We cannot cancel individuals in that block because that's one block. You can't break pieces out of that block. Okay? Locked items, those are. They either cancel entirely or you don't cancel them. Okay? Very important. Good. Just mentioned that. We can continue now. Alright. What is the situation here? This is still, I consider, easy because somebody already factored things. But please, somebody point out the difference between number 8 and the previous one. This one. 7. What's that? Yeah. Everybody was a single factor here. This is block with a single power. This is a separate block with single block. Single block, single block. First power. Everything was raised to first power. Here, you have the same block, y minus 6, over and over 4 times. This is the situation here. You have y plus 4 single. But how many y minus 6's you have? Not once, not twice, not 3 times, but 4 times. That 4 means that brick repeated 4 times. You have a wall of bricks, okay? Now the second block, this one, how many times you have the same brick? 3 times next to each other. And how many y minus 6 blocks? Twice. All you need to do is cancel matching ones now. Can I? Yes, they're all multiplying. As a block they can cancel, not separately, block cancellation. And this is canceling. Just count the leftovers, but combine them if they are the same blocks. So I have 2 same blocks here repeated. So I write them as 1, but raised to 2, exponent 2. And this one is raised to,
Plus 4 to the second.
yes, twice. Okay, this is it. Anything left out? I left out? No. Alright, some people can do it right on the spot. This is first power, this is 3, the difference is 2. This is 4, this is 2, the difference is 2 again. So you put 2 to the top one and 2 to the bottom one. You can do that fast. But I'm just doing this in baby steps for beginners, okay? Any questions? Things are getting challenging because hot served food, ready meal is over. When I say ready hot food, that means somebody did the hard job, got the groceries, cleaned them up, cut them open, cooked it for you and served it. You just diced them, canceled it and got the result. This is not ready because it's not been factored yet. Not been factored. In the last 2 questions you were lucky they were factored. So I called these easy. This was also partially easy because it's kind of factored everything except 81 and 27. You broke them more. Here nothing has been factored. It's completely raw fish. First cut the fish, clean it, cook it. Factoring. Start with the easiest factor skill, 6.1, and apply it one by one. First, I'm looking for something common on the top on both terms. You see the minus? This is not being factored. You need to break something from each piece, left and right. Anything common? B common. I can call one B out of these things. One B common. What else? And 3. Yes. Numbers 18 has 3 and 6. So I can call 1 3 out of each. 3 and B. And 1 B from each. And the leftover things, leftover pieces of the stuff must be dumped here, left out, leftovers. You pull 3B from 3B squared. You borrow 3 and 1B. How many? What's left in the first group? Just B, because you had double B here. Again, you have 3B, B here. You only got 2 of these out, and there is 1 B left. Here you have 3, 6, and B. You borrow 3 and B. 6 is left. Agree? What's wrong? Yeah. Just because you see positive 6 doesn't mean it's positive. It was minus 18. I just broke positive 18 into 3 and 6. You still have a minus sign in front. That carries over here. Alright, next. What's common in this group? 9 and B. Look, 9 is here already. 45 has that 9 as well. 45 is 9 times 5. So I can borrow 1 9 out of these guys. But not only 9, but also B is common in both spots. And leftover, what is left if I borrow these? C left. And what else? 5. Alright, we're done. Let's go substitute this into Connect Math. Agree? At home, do you just cook the meal and leave it on the table? No, you eat it, right? So you did the hard part, factor it, now let's eat it. I mean, cancel, reduce it. Reduce the meal. Leave nothing on the table. Alright, what is reducing? You can only reduce things that have dot among them. So 3 times b minus, there are 3 pieces here possibly can cancel. 3b and this entire block. This is a block. So blocks cancel with other same blocks, but b and 3 can cancel freely. They are separate. So 3 and 9 can cancel, right? 9 has double 3. So when you kill 1, you still have 1 more left. Okay, what else? B and B can cancel. Anything else? Can we cancel anything from these blocks? No, they are too separate. Even this was B. I couldn't cancel B's because they are a block. They are a part of a block. Okay, so just leave what's left in the final answer. B minus 6 left here. And 3 times C plus 5 left here. Okay, if on the either part of a fractional expression there is only 1 block left, nothing else to the right or left of it, do you see anything right or left of this block? These parentheses are redundant, you can clear them because there is nothing to the sides of this block. So just leave it as B minus 6 without parentheses. Can I clean this parentheses as well because there is no more block next to it? Can I? No, because there is a number in front of it. This counts. This still counts. So you cannot clean this parentheses. It's that 3 is multiplying both of them, not only C. If you remove that parentheses, it's just reads C. So this is the final answer. Hopefully the right answer. Have you checked my work? Any questions? So have we simplified this thing? Yes, we reduced it, so it can be simplified. And what was the answer we got? Fraction first. B minus 6. And 3 parentheses C plus 5. Okay, let me double check if yep, we're good. Okay. Any questions? Alright, we're about 70% done here. A few questions left for Monday. Why don't you go ahead and finish it over the weekend? Feel free to do it. And again, go review your chapter 6 for your factoring skills because we will be keep using it all entire chapter and next following chapters. Make sure you signed up